Lesson: Analyzing User Intent, Techniques for Contextual Understanding. Analyzing user intent is a critical component of effective prompt engineering, particularly in the domain of contextual awareness. Understanding user intent involves discerning the underlying needs, desires, and objectives that drive user interactions, particularly when engaging with AI models or other digital interfaces. The ability to accurately interpret user intent can significantly enhance the relevance and efficiency of responses generated by AI, thereby improving user satisfaction and overall system performance. One of the primary techniques for analyzing user intent is natural language processing, which involves the application of computational methods to understand human language. NLP tools can be utilized to parse user inputs, identify key phrases, and extract meaning from text. For instance, sentiment analysis, a subfield of NLP, can gauge the emotional tone behind a user's words, providing insights into their emotional state and intentions. By leveraging sentiment analysis, prompt engineers can tailor responses that are empathetically aligned with the user's emotions, thus fostering a more engaging interaction. Another effective technique is the use of machine learning models trained on large datasets to predict user intent based on historical data. These models can identify patterns and correlations that are not immediately apparent to human analysts. For example, a recurrent neural network might be employed to analyze sequences of user interactions over time, allowing the system to anticipate future requests or preferences. By integrating RNNs into prompt engineering workflows, professionals can develop systems that adapt dynamically to user behavior, offering personalized and contextually relevant suggestions. The implementation of contextual understanding frameworks, such as BERT, has revolutionized the field of user intent analysis. BERT excels at understanding context by considering the bidirectional relationships between words in a sentence. This capability allows BERT to capture nuanced meanings and differentiate between similarly phrased inputs that may have distinct intents. For example, consider the sentences, "I need a ticket for the concert," and "I need a ticket because I lost mine." While both sentences mention a ticket, the intents differ. One is a purchase inquiry, the other is a replacement request. BERT's contextual awareness enables prompt systems to distinguish such subtleties effectively. In practical applications, integrating user intent analysis into customer service chatbots has proven to enhance service efficiency significantly. For instance, a case study involving a telecommunications company demonstrated that implementing NLP and machine learning techniques in their chatbot system reduced call center volume by 30%, while increasing customer satisfaction scores by 20%. This success was attributed to the chatbot's improved ability to understand and address customer queries accurately, thereby reducing the need for human intervention. To address real-world challenges, prompt engineers must also consider the ethical implications of user intent analysis. Privacy concerns are paramount, as analyzing user intent often involves processing sensitive personal data. Implementing robust data anonymization and encryption protocols is essential to protect user privacy while ensuring compliance with regulations such as GDPR. Additionally, transparency in how user data is utilized can build trust and encourage users to engage more openly with AI systems. A step-by-step approach to enhancing contextual understanding in prompt engineering begins with data collection and pre-processing. Gathering a diverse dataset representative of the target user base is crucial for training accurate models. This dataset should then be cleaned and annotated to ensure quality and consistency. Following this, selecting appropriate NLP tools and frameworks, such as BERT or GPT, is essential for model training. These models should be fine-tuned to the specific context of the application, incorporating domain-specific vocabulary and scenarios. Once the model is trained, continuous monitoring and evaluation are necessary to maintain its effectiveness. This involves testing the model against new data and measuring its accuracy in predicting user intent. Feedback loops can be established to update the model regularly, adapting to changes in user behavior and language trends. Moreover, incorporating user feedback directly into the system can provide valuable insights for ongoing refinement and improvement. Finally, Integrating user intent analysis with other technological advancements, such as voice recognition and multimodal inputs, can further enhance contextual understanding. For instance, combining text-based intent analysis with voice-tone analysis can offer a more holistic view of user needs, particularly in scenarios where users may be unable to articulate their intentions clearly through text alone. In conclusion, analyzing user intent is a multifaceted process that requires a combination of advanced NLP techniques, machine learning models, and ethical considerations. By implementing these strategies effectively, prompt engineers can develop systems that are not only contextually aware, but also responsive and adaptive to user needs. The integration of tools like BERT and RNNs, coupled with a commitment to data privacy and security, can lead to significant improvements in user interaction experiences, ultimately driving the success of AI-driven applications.